Welcome to part 3 of my JavaScript intro. In this video I'm going to talk about loops, functions, higher order functions, conditionals, if-else and logical operators. So let's get started. I'm going to start off by creating a dogs array. Equals border collie Jack Russell Yorkshire Terrier Lurcher and Chihuahua. And then next I'll create a basic for loop for let I equal 0, I is less than 4, I plus plus to increment it, and then here I'm going to create a console log and create a template literal backslashes, and then iterator is $I, that's the iterator, and then for the actual dog creates another console log and backslashes again, dog is $dogs I. You've seen this before. So there we are, we've got the iterator, which is the I, and the dog is for each dog. Okay, but I can do another for loop and use a let dog of dogs. So I can go for let dog of dogs, and then I can go console log template literal again and go dog is $dog. And I get all the dogs out again. Another type of loop I could have is a while loop. So let I equal 0, and then while I is less than 4, I'll copy this code from inside the for loop as it would be the same in this while loop I'm creating. And then the incrementer I plus plus to increment the loop goes down there. I get the same output as the first for loop. I get iterator, then the dog, iterator, then the dog 4 times. But a more normal situation where you would use the while loop instead of the for loop is when you're waiting for a condition to be changed by something external, like a user input. Let me show you. let sum equal naught, and let number equal pass int, and then prompt enter a number and then while number is greater than or equal to 0, add all positive numbers, so sum plus equals number, take input again if the number is positive. That's number equals pass int prompt enter a number. And down here, console.log the sum is $sum. This here is the same as if you did sum equals sum plus number. This is just, this plus equals is just an abbreviation for that. If I run that now, enter a number. If I enter a number 5, okay. Enter a number 3, okay. I enter -1. It gives me the sum. What I can also do is a do while loop, which is the same thing, but the conditional is held at the bottom. I'll show you. Copy this down. Control V. And then this one I'll comment this out. And then while occurs here, and then this is a do, and we get the same thing. So if I go 6, okay, 7, okay, and then -1. Okay, I'll get the sum is 13. There are some more loops that take a function as an argument, but before I can show you those, I'd like to talk about functions. Functions are useful for dividing your code into useful chunks. A function is a block of code that performs a specific task. The syntax to declare a function is function name of function then inside these curly brackets you get the code. This is the function body. So to declare the function you have the keyword function followed by the name of the function. Then you have the parentheses. Then curly braces contains the code you want to run. To make the function run, you need to call it. So you go name of function like that. Where's that input coming from? Oh, it's here. So I'll comment this out. That's it. Right, so that function doesn't do anything because it hasn't got anything in the body, but that's the way you call it. Inside the parentheses of the function we can put variables that are used inside the function. For example, let's create a function and call it mySum and give it two variables, num1 and num2. And then I'm going to create a constant result equals num1 plus num2. And then I can return the result. So the way I would use this function is constant returned value equals, I go mySum, and I could put 2 and 3. This will be used as num1 and num2, and then I could console, so log out returned value and I get 5 because it adds 2 and 3 together in the mySum function. What if I have an unknown number of arguments inside the function? In that case I can create a function like the following. Function, I'm going to call this dogfunc for the function, and then dog name, comma, and then dot 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 for the unknown number of dog names. and then console log dog name and dog names. And to call it, I just go dog func border collie Jack Russell Yorkshire Terrier should be an E. Yorkshire Terrier Lurcher and Wow. We have dog name is Jack Russell and the dog names Yorkshire Terrier, Lurcher and Chihuahua. In JavaScript 6 they introduced arrow functions, so you can write functions a lot simpler and you don't need the function keyword. Let me show you. Start with a constant and then a variable name, which for this example we'll just do name of function equals, and then you do an equal sign and a greater than symbol and then curly brackets, and the function body goes inside these curly brackets as before, and then it's called in the same way. I think I'll call it name of function 1 so it doesn't clash with the other name of function that I created. That's it. It doesn't do anything, of course, because there's nothing in the body. But that is the form of it. And you can have it all in one line, so you could have constant name of function 2 equals, and then if you have say just one line of code, say console log I am just one line, when I call that function 2, I get I'm just one line. Notice that when you use an arrow function in just one line, you omit the curly braces. The way I like to think of arrow functions, and which helps me understand them, is if you divide them into two halves, first half being constant, and then the name of the function is like setting up a variable, and then you have equals, and then here is just an anonymous function. Instead of functions and then parentheses, you have parentheses and the equals and greater than symbol. You can add arguments to the parentheses as well in the same way you can in a normal function. So I can rewrite the dog function. I call it constant dog func1 equals dog name dot 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 dog name dog names console log dog name dog names. And you call it in the same way, func1 1. I'll copy these dogs. I get the same thing. Also, I can write this as a single line function. I can take out the curly braces. Make it a single line function. It still works. I'd like to talk now about logical operators. Logical operators are used to compare conditionals. Okay, but what are conditionals? Conditionals are used to test variables for either true or false. So for example, if I set a constant j equal to 6, then I can create the following conditionals. J is less than 5 will evaluate to true because j is 6 and 6 is greater than 5. So that is true. J is less than 5 will evaluate to false because j is 6 and 6 isn't less than 5. Logical operators are AND represented by two ampersands, or represented by two vertical lines, and not represented by an exclamation mark. Let's start with an AND operator. We can create a truth table, so we can have two conditions, X conditional and Y conditional, and a result, so that when X is false, Y is false, the result is false, and when X only is true, the result is false, and when Y only is true, the result is false, and when both X and Y conditional are true, then result is true, and that is the only condition where it is true, when both X and conditional and Y conditional are both true. So if I set a constant X to true, and a constant Y to false, and a constant Z to 6, I can set the following logical examples. Console log X and X gives true because true and true evaluates to true. Console log X and Y gives false because true and false evaluates to false. And console log Z is 6, is greater than 3, and Z is less than 3, evaluates to false because it evaluates to true and false, which evaluates to false. Now let's do the OR operator. We can create a truth table as before. False and false is false, true and false is true, and false and true is true, and true is true. So the only one where the result is false is when both the X conditional and Y conditional are false. To remind you of our variables, we have a constant x equals true, constant y equals false, and constant z equals 6. So console log x or y is true because you have true or false, which evaluates to true. Console log y or y is false because false or false evaluates to false. Console log z is greater than 3 or z is less than 3 gives true because true or false evaluates to true. You can do the logical not. Logical not is just the reverse. So you have, when you have not x, x is true, so it becomes false because not true evaluates to false, and not y, which originally was false, becomes true because not false evaluates to true. Next I want to talk about high order functions. For this I'm going to copy and paste an array of dog objects. A higher order function is a function that takes one or more function as arguments, or it returns a function as a result. The higher order functions I particularly want to talk about are inbuilt functions that take a function as an argument and are used for looping through arrays of objects or an array of arrays. More specifically, I want to talk about the inbuilt functions. For each, map, filter, sort, and reduce. I'm going to start by using the for each to console log all the dog breeds. So I go dogs obj dot for each dog, and then dog is the object in this array of objects, so inside the dog we get the breed, so it's console log dog dot breed. There we are. I have all the dog breeds console logged out. So a for each is good for looping through the array but does not return anything. A map, on the other hand, returns an array. So I could return an array of dog breeds. Call this constant dogs breed equals dogs obj dot map is dog, and then return dog dot breed, and then console log dog dot breed, console log dog dogs breed, and I get an array of dogs. Okay, so now I'm going to do filter. And then a filter enables you to filter out, and then what I'm going to do is filter out the border collies, because there should be 2 of them. Constant border collies equals dogs obj dot filter dog and return dog dot breed equals border collie. Then I can console log the border collies. I get an array with 2 border collies, which is Lucy and Betty. So on to the sort function. Sort. The sort takes a compare function, and that takes 2 values, which I'm going to call dog1 and dog2. If dog1 is less than dog2, then -1 is returned. If dog1 is greater than dog2, then +1 is returned. And if dog1 and dog2 are equal, then 0 is returned. The sort function takes the values returned by the compare function, and if it gets -1, it puts dog1 before dog2, and if it gets +1, it puts dog2 before dog1. If it gets 0, it means they are the same, so it just leaves them as they are. I'll create the compare dogs function. Function compare dogs, dog1, dog2, then if dog1 is less than dog2, return -1. If dog1 is greater than dog2, return 1, 1. Otherwise, we just return 0. So now I'm going to use the compare dogs function in the sort function, and I'm going to sort the dogs by dog name. So constant sorted dogs equals dogs obj dot sort, and then in brackets dog1, dog2, and then compare dogs dog1 dot dog name, comma, and dog2 dot dog name, and then I can console log sorted dogs. I should have my sorted dogs here by dog name. Betty, Binky, Freddie, Lucy, Ozzy. That's in alphabetical order. That's what I wanted. So now on to the reduce function. Reduce. The reduce function takes a function as an argument and uses the supplies function to reduce the array to a single value. A simple example of this is a sum function. If I create an array of numbers first, constant numbers equals 5, 7, 4, 8, 3, and then a function sum with two arguments, a, b, and then we'll return a plus b. So now I'm going to use that in reduce function. Constant num totals equals numbers, our numbers array, dot reduce, and the A is an accumulator. This the current value is added to the accumulator each time it gets a new current value. So sum accumulator and current value, and then you initialize it to 0. That's the initial value of the accumulator before it starts. And now our console log num totals is num totals, and it gives me 27, which is the total of these. I'm going to create another more complicated example which allows us to group objects in an array. More specifically, I'm going to create an array of dog objects, and I'm going to group the dogs by the dog's age. So first I will copy dogs obj2, which is similar to dogs obj but has the dog's age added. So now I create the function group by function group by, and we've taken the array, the dogs of obj2, and a prop, which in our case will be, the property will be the age of the dogs. Return arr dot reduce accumulator current obj and then let key equal current obj square brackets prop. So this will return, will make the key equal to the value of age. in the current object. So if not accumulator, if it's not in the accumulator already, okay, if it's not in the accumulator already, then just create a new place for in the accumulator with the key and set it equal to an empty array. But if it is there, the accumulator key is used, and then you push it, the new value, which is current, push the current object onto the particular array. Return accumulator. Right. And this is initialized as an empty object. I'll put some comments in here. So this makes the key equal to the value of age and this initializes an empty array if it is a new key. And this pushes the current object onto the correct array group, and then this just returns the accumulator. So to try we'll try that out. Go constant grouped dogs equals group by, and then dogs obj2 age, that's what we want it to group by, and then console.log grouped dogs, and there we have our arrays of dogs, and they're grouped by age. This one is 1 year old, age 4, and that one's age 5. I think I'll leave it there for this video. Thank you for watching. If you enjoyed this video, then please subscribe for more.